Welcome to video 2 for chapter 2. In this video we will talk about values and variables. In programming, there are two V's you always have to keep in mind, and if you remember things in terms of values and variables, a lot of things are easier to remember. What is a variable? A variable can hold a value. Okay? Values are stored into variables. And we're also going to talk about input and output. By now, I hope you remember that if your program has to perform input or output, then there's a certain preprocessor directive that must be present in your program, and that directive is pound include uh, less bracket IO stream right bracket greater than. Okay, now let's get started. Now, in a program in algebra, we typically deal with variables and constants. A constant is a value that doesn't change. So a constant in a programming language can be different types of data. We are very much accustomed to integer constants or decimal constants like pi. But there are also constants for characters. And a constant for a character is indicated by a single quote as a delimiter. A single quote begins the character, a single quote ends the character. In between the two single quotes must be exactly one character. A string, on the other hand, is indicated by a string value is indicated by a double quote, which means between a double quote begins the string and a double quote ends the string. In between the double quotes you can have 0 or more characters. So technically we can have a string that is indicated by double quote, double quote. How many characters are in such a string? 0. Is that a valid string? Yes. Does it have a name? Yes. It is called the empty string, or sometimes it's also called the null string. Let's get back up here. When we say the word constant, another term that's used to indicate a constant value is called a literal. And one way of thinking about a literal is that the value is literally what you're looking at. What is the value 12? Well, the value 12 is literally what you see there, 12. All right. Now, what's a variable? A variable is a location in your random access memory where you can store, where the program can store values. Consequently, if the program can store values into a variable, it can also get values out that are stored within a variable. A variable has to have two attributes. One is a data type, the other is a name. Recall that we said that the name that we use, the symbols that we use to name things is called an identifier. Do you remember the rules of an identifier? Yeah, an identifier must begin either with an underscore or with an alphabetic character, and all the other characters can be either a digit or an alphabet or an underscore. All right. Now the rules about variables is that a variable doesn't exist until you create it. Once you create it, you can begin to store values. And once a value is stored in a variable, that value can be changed later. Hence, you have the word variable. That is, the value can change. At the same time, a variable can only hold one value at a given time. So if you have a variable, in this case age, we're declaring a variable, we're creating a variable called age. It can hold what's int. It's an integer. It can hold whole numbers. Now we can assign it the value of a whole number 17. After this statement executes, the value of age is 17. So if I were to output the variable age, this really says output the value of the value that's stored in variable age. And we see from the line above is 17. If I change the value of age, setting it to 18, then if I output the value of the variable age again, the most recent value will be output. The only value that it knows at that point is 18. It never knows that it had 17 in it previously. Let's talk about the different types of variables. A decimal number, a simple decimal number, the corresponding data type is float. If you have a string of characters that you want to treat together, it's called a string. For example, the course that you're in is COP 3014C. To describe the course requires a sequence of characters, including a blank character. The data type char says a variable that can hold exactly one character. Notice that in this case, I am creating a variable and I'm giving it a value at the same time. We call this initialization. We're declaring a variable with initialization. So as the variable is created, it's as if it is born. For example, it's as if gas cost is born with the value 2.97 in it. Right. There are other data types. One is called long. Long means an integer that can have lots of digits. For example, this is a silly guess at the global population. And this number, if you look at it, is like 7 billion. All right? The basic data type int does not count up to 7 billion. So long is a long integer. Short is a short integer that is shorter than a regular int. So if you have very small quantities like people's age, short is adequate. The data type bool is a variable that can hold a value that's either true or false. Notice that in C++, all the data type names are keywords. So how do we declare variables? Again, we say it's a data type followed by an identifier. We can identify, in this case, we are declaring two integer variables, length and width. We are declaring them with two declaration statements. Or because the data type is the same, I can, with one declaration, declare both of these. I can declare it this way, or I can declare it the way I had it. That is, what does the compiler care about? You're starting a declaration. Here's one of the variables. The comma says, whoops, there's one more variable that we want to declare to be of type int. And it comes after the comma. And here is that variable. And then the compiler says semicolon, which means it is finished with the declaration that you're doing. If I have one variable that's an int and one that's a float, I need two separate statements to define those. Now, the question is, we talked about creating a variable, and the question becomes, when does the variable get created? Well, it gets created when you declare it. All right? How long does it live? Well, the variable keeps living from the time that you create it until the time that you leave the block in which it was declared. What does a block look like? Y'all remember? A block looks like open brace, close brace. So if I declare A in here, the moment the program hits this delimiter, all the variables that were declared in here no longer exist. Okay. Now, what are ways you can give a variable a value? Most of these you have seen before, but I need to remind you that there are three ways. One is we can initialize a variable when we create it. We can read a value into a variable, that is, we can do input, or we can assign a value. What does this statement say? It really says, I want to put a value into this variable over here. Go over on this side, and it tells you how to come up with that value. And how do we come up with that value? Well, we take whatever the value of age is, add 1 to it. If perchance age was 19 up here, I have these switched around. So it will produce a value 20 if in fact age is 19 when this statement is executed. Let's talk about an input statement. Input in your programs from the beginning will be from the keyboard, and the data that you get from the keyboard has a name. It's called the standard input stream, and it is indicated by the keyword CIN. So whenever you see a line that starts with CIN, it says what? You're trying to get input. You're trying to do input, and you're talking about input that is typed in at the keyboard. Now, how is input actually obtained? It's really obtained by this operator, greater greater. Because greater greater's job is to extract data from the input stream and take that data and store it into a variable. All right? And you can read one variable, or you can read multiple. You can read one value into a variable in a statement, or with one statement you can read values into multiple variables. So how does that work? It says we're going to get data from the standard input, which is the keyboard. I want you to obtain a value for variable 1. Then I want to obtain a value, extract a value for variable 2. And then we extract a value for variable 3, and so on. So what is the name of this operator? It's called the extraction operator. What is its purpose? It performs input. Let's look at the assignment statement. We have seen it, and it kind of means the same thing as it means in algebra. Because when you write an equation in algebra, we typically have one variable on the left-hand side, an equal sign, and we have any kind of algebraic expression on the right side. The expression could say 3 plus 5x minus 4. It can be any expression which, if you carry out the operations in the expression, will result in a single value. All right? So let's talk about the parts. The equal sign has a name. It's called the assignment operator. Assignment operator. What does that mean? Assign a value to a variable. On the left-hand side, you have a single variable. On the right-hand side, you have an expression, and this expression must produce a value. Why is that? The assignment statement says store a value into a variable. So the expression must yield one value because a variable can only hold one value. So here's some examples. X is assigned the value of 14. This is an expression. Whoa, what do we call this? Oh, it's a constant. A constant is a value, and an expression is anything that ends up with a value. So one form of a value is simply a constant. What about here? How do we compute the value here? This says compute a value by taking the value of variable x, multiplying it times 2, and that will give a single value that you now store into x. So arithmetic expressions, again, are expressions. And what's this? X. What do I want to do? I want to store a value into y. What value do I want to store into y? I want to store the value that x has. I want that same value to be stored into y. So when you see an assignment statement, you must remember the sequence in which things occur. The first set of action occurs on the right-hand side. The expression on the right-hand side is evaluated to produce a single value. And the second step is that value that you get is then stored into the variable on the left-hand side. Let's talk about output. When you want to do output, the default or standard way of displaying output is to put it on the computer screen or monitor. Whenever you see cout, it refers to output to the screen. It's called the standard output stream. And there's an operator that actually puts things out. Cout simply identifies the destination. Just like with cin, we have the operator greater, which we called extraction. Its job was to pull data out of the input stream and store it in a variable. For output, the operator less, which is called insertion, has the job of inserting a value into the output. In this case, what type of value is this? Begins with quotes, right? Double quote, so this must be a string. What is the value? The value is everything in between the quotes, but not the quotes. So what will show up on the screen? The word hello, comma, space, there, exclamation point. This only. Silly thing. This only. Just like you can read multiple things, you can output multiple things. You can say output the string hello, comma, space, followed by the string there. Okay? Good. Finally, how do you start a new line? Normally on the screen you may have multiple lines of output. The value in line simply tells you to insert a blank line. All right? So this says print out hello there and do a carriage return. Hit enter so that after you print this, you are on the line below. If you're printing a string, you can embed a backspace into an output string, and that has the same meaning then of inline. It says skip to a new line. All right, we're going to terminate right here. Part